Hi, my name is Arvelyn Hill, and I'm the manager of the Everett Children's Adventure Garden at the New York Botanical Garden. Today, we are going to be exploring cones in the garden today. Cones come in many different shapes, sizes, and colors. Behind me is one of our cone caterpillars that we have on display in our garden. So let's take a closer look to see what we can find out about cones. This is a Norway spruce cone. It can be identified by its unique triangle-shaped scales. It is the largest cone of any spruce tree, growing up to be 6 inches in length. Norway spruces are almost always the tree that is chosen at Rockefeller Center. Here is a Eastern white pine cone. Their cones reach 4 to 8 inches long, and each scale has an end wing. Eastern white pine can live to be over 400 years old. Indigenous people would traditionally use pine resin, which is the white sticky stuff that comes from the pine, to waterproof baskets, pails, and even boats. This is a ponderosa cone. Its reddish brown cone reaches about 4 inches in length. It has a stouter shape, and it's named for its ponderous, heavy wood, and it is a major lumber tree in the southwest of the United States. This cone is a sugar pine cone. It's the longest cone of any conifer, with an average of 14 inches coming from the tallest pine tree, which reaches 200 feet tall. It gets its name from its sweet scented resin, which you can see residues from on the tip of this sugar pine cone. So friends, I was taking a closer look at this Eastern white pine cone, and there was something that I found that I want to show you. I was looking at the inside of a pine cone, and I saw these leafy, almost delicate paper, brown paper-like things inside. Let's see if I can use my special science tool, these tweezers, to take it out to see if we can figure out what this might be. It's all the way nestled into the scale here. Here it is. Do you have any idea what this might be? Maybe it'll help us figure out what is the function of a cone. So there's seeds. There are seeds all inside this cone, nestled into each and every one of those scales that we were just looking at. Now we're going to look closely at an experiment that we're going to do together to learn more about the function of a cone. All right, friends, now that we took a closer look at some cones, we're going to do an experiment together to find out what we can find out is the function of a cone for a tree. So for this experiment, you're going to need 3 pine cones. They can all be the same type of pine cone. They don't have to be different. And then you're going to want 3 cups or jars, and you'll need warm water, cold water, and then 1 jar that you're just going to leave with air in it. So you can gather your materials now, and we'll get started on our experiment. All right, now we're gonna get ready for our pine cone experiment. And for this experiment, you're just gonna need a few jars and some pine cones. So I have 3 jars, each which I labeled. One I labeled saying warm water, the second says air, and then the last one says cold water. And you can go ahead and put your pine cones in your jar. I am using a Norway spruce pine cone. Each of these pine cones are the same. And so I'm going to put each of them in their jars, And if you want, you can also get a piece of paper and pencil to have handy so that you can make observations of what you see. So next what we're gonna do is I'm gonna put warm water in this one jar. I'm gonna leave this other jar empty, but just have air, see how it observes with just air, and then the last jar with cold water. So let's take a look to see what happens. All right, I've been observing my cones in their different water temperatures to see what happens. And after 20 minutes, I was really shocked to find that they changed. Even before 20 minutes, really quickly, things started to happen. In my cold water jar, the pine cone slowly started to seal up and close its scales right here. But it happened really slowly. My other pine cone that was just in air stayed the same. It was just a comparison for the other two. But my one that was in warm water sealed up really, really fast. And just 5 minutes, it started to seal up. All those scales closed right up, and it even changed in color compared to the one that's in cold water. It got even smaller. So why do you think this happened? Why do you think this pine cone started to close up when it was in these different temperature waters, whether it happened fast or slow? Take a moment to think about it. So pine cones are so cool. They have amazing adaptations to help the conifers or evergreens grow. Cones seal up. They seal up to protect their seeds. So next time you're out exploring, take a closer look at a pine cone and try this experiment and see what observations you can make. I hope you enjoyed this activity, and I'll see you next time.